Right. Yes, it is. And I will start that presentation. Okay, here's about. Just a short reminder about the project. So VeriDevOps is about automating analysis, verification, security requirements, getting into tests and verifying operations. So with monitoring tools. What we want actually, we want to address security from requirements to development and operations. As you probably know, the number of security vulnerabilities has grown dramatically since 2002. It's doubled since 2012 and going faster and faster. That's because of various reasons, including that we have more and more software currently, and more our world is run by software. We have so many different specialists, and not particularly is aware of security vulnerabilities and the ways to deal with security. So to that, we want to address the security from the beginning, from requirement specification to development practices and to operations through various techniques. Just another example from the industry, that's mostly like vulnerabilities are hardware, like network vulnerabilities, but also quite a lot of progression in terms of application vulnerabilities. And among those application vulnerabilities, we have lots of critical vulnerabilities that has to be addressed. We think vulnerabilities and requirements are quite linked, and requirements many times. Yes, Anna, hello. Let me continue. And requirements are the development of the systems and system operations. So to say that, I mean, we see that many systems are prone to security vulnerabilities, like 80%, 70% have more than one vulnerability, and 20% have more than 10 vulnerabilities. Right. So VeriDevOps project. So we had the concept for this research project, whereas we drive all analysis of the systems through formal specifications. And we start with some kind of textual description, natural language of security requirements, vulnerability attacks, attacks descriptions, vulnerabilities and attacks descriptions, standards, but also requirements from the users. And through specific steps like natural language processing, formalization, we get into formal description of the systems and properties of the systems. And from that, we can automate many different things like at operations, configure various monitoring tools to find out what are the anomalies, what are the attack signatures, and so on. But also in development stage, we can run design checks, so we can run and continuously verify and address the requirements. And I believe your work will be somehow related to all these various topics. And I guess this picture would actually drive our today's seminar. So we'll start with some of the techniques. We'll go through like DevOps techniques in the same context, through monitoring techniques, testing techniques, to NLP. And so with that, we will see the whole picture, the whole different bits of research that will fill this picture. Okay. I guess that would be end of my introduction. So I will give word to our colleague, Ildar. Ildar,
yep.
You can share your screen.
One sec, please. Please let me know when you can see my screen.
Right. Just a small thing. Any questions to this introduction presentation from anyone? Right. If not, yeah, Eldar, you can start.
Okay. Thank you, Andrei, and it's a good introduction. And my work is a part of the global thing that Andrei in our team is involved. And my focus of my PhD thesis is requirements as a code. And I consider functional and non-functional requirements. And for next 10-15 minutes, I will talk about what issues I see, what solutions I can propose, and what possible benefits I can bring to industry. And let me start from introduction. Currently, I'm a PhD student at Innopolis University. Also, I'm a teaching assistant and for Innopolis as well. And in parallel, I'm a project manager in industry, and I have run a lot of projects for some big companies and some different domains, and started from Microsoft, also for government in Russia and banking in Europe and Russia. And my career started from QA engineering. And that's my experience. It reflects the topic that Andrei proposed me about half a year ago. And when he talked about the requirements as a code, and for example, his focus was on security requirements, and it reflects my personal experience. And the first question that I asked myself, why security requirements are important? Since I started as a QA and worked on QA engineering and quality assurance domain, and as a project manager, I worked a lot for banking and government, where security was the cornerstone for each business. And any client asks us about how can you ensure, guys, the security, and how can you guarantee that no personal data will not be leaked somewhere, and you have to avoid some backdoors. And in that case, we proposed a huge list of security requirements in technical specification. Also, I started analysis of some vulnerabilities and some top 12 top 10 some security vulnerabilities, and I see that, for example, broken access control, some injections, cryptography failures, it happens, and for now it's the most important thing in security. And also I saw the statistic of the vulnerabilities, and it raised dramatically. As you can see, 2021 year is not ended, and we see that the magnitude is high. And in that case, I thought about what if I analyze security requirements for some, how to say, specific domain, and I pick up Windows 10 operation system and security requirements for that operation system, and how can I structurize and enhance them. And it was on the upcoming slides how I can propose that case. The second question, what I ask myself is, it's really challenge to ensure some change request and requirements traceability, since when we have a lot of, how to say, in government, in banking domain, we have some changes in requirements, for example, in some rules, compliance, etc. And we need to ensure that this part is taken into account in the source code. And how to ensure that part? How we can guarantee to client that all his requirements are stable, not just in the code, but stable and robust, and we can guarantee that it works correctly. And when I analyzed some dozen of literature, I found out the following things. First of all, we need to simplify ways how to do that. We have out of date about 30 years old standards released by Department of Defense in the mid of 18th, and also I found out that there are a lot of inconvenient tools that can guarantee some traceability between code and requirements. And my challenge and my question was how we can ensure that it can be applied to industry and we can simplify a way to ensure traceability when we have a lot of codes, how to say more than 1 million line of code, and how can we apply some, how to say, pattern that can simplify and structurize these requirements and run it as a piece of code and map change the requirements and code base. And the third challenge, and it reflects my experience as well in how to support automation tests. Sure thing, if we have some small project, it's not a big deal to maintain. But what if we talking about more than 1 million line of code, right? And what if we need some convenient tools and languages to apply for some test cases? You have to ensure traceability between test cases and requirements, some kind of traceability matrix, but in terms of the code, testing code base. And it was my third challenge. How can our idea of patterns can guarantee that it can be simplified? And then the third thing that I'm going to verify in my upcoming PhD thesis. And the solution that I can propose to industry in the area of analysis is the requirements as the code patterns. First of all, let's get back what's requirements. I consider both functional and non-functional requirements. Just to refresh, if you guys, someone don't know, functional requirements, what we put in their requirements specification, and we see the behavior of the system in terms of its functionality, how it should work from user perspective, right? And non-functional, we focus on attributes, a kind of performance, security, stability, maintainability, etc. So in my case, I consider both of them since I know that both of them are described in the some list of list of requirements, and they all have metrics, and I can structurize them. That's why I cover both functional and non-functional. For that purpose, I thought about different ways of how can I use structure of requirement description, how can be useful. And the first point is what caught my eyes is OOP paradigm. So I know that OOP paradigm, when I was an automation tester many years ago, I used OOP sometimes, and I know that it has inheritance, some polymorphism principles, and this thing can be applied to my patterns. Let's say, in a nutshell, for example, we have requirements. Let me. So this is example of security requirements for Windows 10. That's the practical thing that I'm going to consider. And this in the left column, we have IDs and severity and title, and each of these requirements for Windows 10 has its own some parameters and its own structure. And what if I compare, for example, pick up one requirements and compare it to another requirements, and I can make some parent class, some kind of user account management, right? And these subclasses can be covered by my parent class. In that case, I can create a parent class and see dependencies between subclasses, right? And for example, if I run some pattern that covers user account management, it covers all this subset of subclasses related to user account management. That's the point, guys, to simplify the way how to guarantee the coverage and how to simplify these requirements. And my point about test cases is to find the way how can it simplify. And one of the areas of my research is to consider the tool called Cucumber. Cucumber has its own natural language to create a code for description the test cases. That's the approach I'm going to take for my work and apply it and see how can I using the same OP paradigm and, for example, take a lot of test cases. How can I simplify, find dependencies between test cases, test suites, for example, huge blocks, and down to test cases, and make these patterns. And finally, what benefits can I propose to the industry? That's my primarily goal, to bring some value for industry, and not just paper for paper. It's for real thing that's real change for me as a industry representative. First of all, is simplify, requires traceability, reduce time for test case support. And in my case, I'm going to not just to consider only stick requirements as a security, but consider another requirement security and see how can I enhance security coverage, enhance the security overall for some systems. That's the point. That's it from my side. Thank you. Should you have any questions?
Yeah, okay. Just to recap, this is kind of a starting point for this PhD thesis on requirements as a code. Dar has just started his thesis work and his few ideas on where he plans to go. Okay. Any questions from the audience? Okay. Otherwise, I propose we switch.
I'm stop sharing. Thank you, Andrei.
Yes,
Thank you,
yes.
everyone.
Olga, Rufina would like to share.
Okay, let it be me.
Mm-hmm.
Do you see now my
Yes.
screen?
Yes.
Okay, let's start. Good afternoon, everyone. We are happy to present our semester thesis work that we have done. Currently, we are a bachelor's student, fourth year student, and this is the work for our thesis. Rufina, I'm giving the word to you.
Okay, here we would like to describe a software development lifecycle by stages. First stage is requirement gathering from customers, so product owners. The second stage is constructing some software requirement specification from that gathered requirements. Afterwards, we construct software architecture from this document. The fourth step is to design the code from the software architecture. The fifth step is to test our code. If some defects are assigned to developers, they should fix them. If the product is tested and no failures appear, then overall our software is developed, is deployed into development environment where a customer can observe how our software is performing. And if customer is happy with the results, we deploy this software to the production environment. So, and in the production environment, if there are issues comes up, we report these issues to customers and fix our software, and this life cycle continues to repeat.
So currently the tendency is to automate and make this software development lifecycle continuous. And from this, we obtain the CI/CD pipeline, or in other words, DevOps pipeline. And there is the main reasons why we need automation and continuity. First of all, the quality of produced software increases, and also the speed increases. That is because the feedback loop from code production to getting some feedback on this code is decreased. So developers could fix the bugs earlier, and also continuous testing provide us with opportunity to monitor quality more often. We can see here some tools and that are mapped to stage. Build stage is currently automated with the use of such tools as Maven, Gradle, or simply writing some shell script and executing it. Also, test stage is automated via the same tools, and also we can perform Docker container scanning with Travi or Snook, and perform static testing with Sonar. Release stage is automated using plugins in CI/CD platforms, or if someone is not using the CI/CD platforms, the same, we can just write shell script and execute it. Deploy stage is basically automated by the use of GitOps. So whenever there is a change in architecture or in code in GitHub or any other version control tool, our architecture is changed, and our changes are deployed to development or to production. We can say that operate stage is automated via the use of load balancers. So whenever the load to your application is increased, some other containers are raised and the load is balanced between them. And when the load gets less, containers get killed, so we do not use any resources more than we need. And monitoring stages are automated by the use of different monitoring stacks. Probably the most known is Grafana, Prometheus, and Alert Manager. So looking at this CI/CD pipeline, we plan to achieve the transition from requirements to the written tests. And this is going to be automated in CI/CD environment. Let's take a look at state of the art in literature review and see why this task is not yet done by somebody else. Well, here I have chosen some important papers from the field, and basically we can structure the three general cases. First one, the preprocessing is required to build test cases from requirements. Second one, other works produce not readily executed tests. For example, the first one paper produces abstract classes, and the implementation itself should be written by developers. So this code cannot be executed just from the start. And also, we can see that several papers are really domain specific. They are specific to autonomous vehicles. And as well as the researchers say, they plan to apply their approaches in the industry and see if it works there. So it is not even guaranteed to work in autonomous vehicles domain, and therefore it's not guaranteed to work in the general case.
Okay, now we want to present our methodology. We already refactored our code repository structure where the source code and tests for now are written manually by developers. Move the whole project to Maven framework to easily build and test it from the shell, and create sample pipeline that runs all tests that are present in the repository. For now, we are conducting feasibility study. It is in progress, and we want to the future work is to create plugin for GitHub Actions for now that accepts simple trained ML model and some texts as input data and return some predictions. And the further work is to apply our plugin to real ArcCode NLP model that will be described further, I think, in further presentations. Create additional plugin for parsing predictions from that NLP model and constructing Java tests from them. Here our pipeline, GitHub Actions pipeline for now. When requirements on the right, you can see the Git repository structure example. And when requirements txt are modified in Git, for example, customers or product owners want to add requirement or delete it, CI is triggered for generating tests, new tests, according to updated requirements. Then our plugin takes NLP model and requirements as input and returns some predictions. Additional plugin takes that predictions as input, parse them, and constructs Java tests. If predictions cannot be able to parse, then report is generated. Then, if everything is okay, Java tests are pushed to Git system tests folder. After the push of tests, then CI build is triggered. Project then is built and tested using Maven framework. If tests are not runnable, report is generated as well. If tests failed, report is generated because requirements are not passed for our system. If no fail steps occurred, then system is deployed to our server. So by this pipeline, we ensure that requirements are met with our system.
Here we observe some risks that we may face. First of all, our pipeline may not be applicable in general case. For this, we decided to design CI/CD plugins for the most popular CI/CD platforms, for example, GitHub Actions, Jenkins, and CircleCI. The second risk is that currently we do not have the transformer prototype that transform the requirements into Java test class. For this, we agreed on the input and output format so that we do not stop our work for prototype. And the last one is we should provide feedback if something fails in the pipeline. And actually, this is the same as for applicability in CI/CD platforms. Not everyone uses the same means to provide feedbacks. And in this case, it is even more complicated to agree on some general case. So here we would appreciate some suggestions on how to fix this. Well, our secondary goal that we may achieve during our research is comparison of CI/CD platforms. We can check, is it easy to develop some custom plugins on these CI/CD platforms? Is this platform free for use on open source projects, on private projects, and also check if there is limitations on resources, speed, flexibility, and so on. So currently we can say that requirements to test generation optimization is not largely represented in scientific community. We suggested a pipeline to employ the machine learning model for the purpose of transforming requirements into Java code test classes. And currently, we are going to show some demo of this pipeline, and we would be glad if you suggest some improvements on our feasibility study. Let's move to demo. Here we have two workflows. So first is the requirements push. So we have specified the folder where we store the system requirements. This is obvious. And whenever a new requirement arrives, we use machine learning model emulator and produce a test class from this requirement. So as we said, currently we do not have the actual machine learning model, so we are using some Python script just to emulate it. And these classes, test classes, are committed to test folder. The test folder is here, src, tests, and some classes. The second workflow is currently run on test push. So whenever new tests arrive, all the tests are executed. For now, let me stop the workflow dispatch on push so that we do not miss anything, and leave just manual dispatching. Also, here we have requirements folder with some requirements, and as I showed, we have Java tests. Let us start from the beginning. So let's delete all the requirements and all the tests. Also, it's worth to mention what is performed in machine learning model emulator. So here I just know which requirements I'm going to use. So here the requirements is just checked for some patterns, and according to these patterns, Java classes are generated. Okay, let's delete tests also, so that the directory would be empty now. And let's start. I'm going to use this Ubuntu stick. So this is the system specification. And here we can see how we may check whether it is satisfied or not. Okay, our requirements folder is done. So let me do the following.
Hi, Olga. I don't think we see your screen, so we just see kind of fraction of a screen.
Oh, I'm sorry. Okay. Let me share the whole working process now. Do you see the screen now?
Yes.
So I created requirements folder, and now let's add a requirement. We are going to use this one. So I'm going to copy the name. And I'm going to copy the whole content of this stick. We can see that our Git repository is updated now, so I'm going to commit this. Okay, everything is pushed. Let's go here. We can see that requirements folder has appeared, and we have this stick here. And also, if you go to actions, we see that the action that should run on new requirements is triggered. And here we can see that we generated Java tests with this machine learning model emulator and committed these changes to SRC tests folder. Now let's check. Yes, the test has appeared 30 seconds ago automatically. And now let's go to actions. I turned off the automatic run of this job, and now I'm going to trigger it manually. I'm running this workflow. And let's see what happens. So here we checked out the repository, set up Java, and here we execute tests. As we see, the tests have failed. So here, what we needed to check is see whether the PAM last log file is present and that it is set to required and no silent mode is present. So our test has failed, and we may see the file entry. As we can see, PAM last log is set to optional. So this violates this requirement, and therefore our tests have failed. Probably that is all for the demo part. We would really appreciate suggestions on how to improve this pipeline and how to conduct the feasibility study. And if you want to contact us, here's our university emails. Thank you for attention.
Thank you, Olga. Thank you, Rufina. Yeah, very nice presentation that I first time I see that. So it actually runs very smoothly and good. Thank you. Now from the audience, do you have any particular questions?
Yes, Andre, this is Jean-Michel.
Hi, Jean-Michel.
Yeah, very nice presentation, very nice work. I'm just a little bit puzzled by the use of files, but I understand the concept and everything. But in terms of traceability, do you foresee a way to, when a test fail or when a test pass, to somewhere in the list of requirements, know which one have passed and which one have failed? Because I don't see, I mean, apart from reading some kind of reports, I don't see a quick and easy way. If I have like 50 files, 50 requirements files, which one have passed and which one are satisfied and which one are not. So I was thinking at first using more issues, for example, then you would be able to tag the issues, or I don't know. But so my question is, how do you trace back to the requirements the fact that the tests have failed? Only because the push has failed, or I don't know if you get my question.
Thank you for the question. Yes, you are right that in case we have more than like tens of requirements, there's going to be a mess here, and actually we planned to structurize them and add some tags. And for now, this is a demo pipeline, so we didn't add some enhanced structure. And also, as we mentioned here, we are planning to provide feedback on the pipeline failures. So the feedback is going to be detailed and specify exactly which requirement has failed. And for now, we did not come to an agreement of how to generalize this feedback, like how to make it applicable in general case, so that it would be convenient for any user.
Okay, thank you very much.
Very nice suggestion, Jean-Michel. So we'll be looking at this one in the issues and reports. Also, yeah, a nice thing to look at. Any more questions or comments from the audience? Damir, you are working also on DevOps practices. So any comments on the demo?
Yeah, not really.
Not really. Okay. So
but there might be something that like once I do my presentation, there might be something that could be interesting too. Perhaps we could do something together.
Okay, good. Thank you. Right, thank you very much, Olga, Rufina.
Okay, thank you.
So Zuhani, we can switch to your presentation. So you have something. So Zuhani, are you here? Are you ready?
Yes, hello everybody.
Hello.
Can you see my screen?
We can see you, but
me only. Okay.
Not yet.
Now?
Yes.
Okay. Well, hello everybody. This is Suhani Salazar from Montimash, and my presentation will be about security monitoring. First of all, let me introduce myself. I was born in Venezuela and currently I'm living in France. I'm a first-year PhD student on security monitoring of 5G networks. This is an industrial PhD arrangement between Montimash, a small company based in Paris, and the Université Paris-Saclay. I have a Master of Science in Computer Science for Communication Network of Téléconsult Paris, and my background is in electronic engineering, telecommunications, and cybersecurity. I'm currently working in 2 European projects, VeriDevOps for monitoring industrial control systems, and Sancus project for monitoring 5G networks, where I'm actually doing my PhD thesis. The presentation plan of today is, first of all, a motivation about why it is important to perform security monitoring. Then I will provide you with some basic concepts about monitoring, including the different approaches of the intrusion detection systems. Then I will talk about the work I've been doing and in general Montimash will be doing in the VeriDevOps project. And then I will give you a short pitch about my thesis. Why monitoring? First of all, I would like to present you some insights provided by Kaspersky, an important actor in the cybersecurity. They study the current state of industrial cybersecurity in the era of digitalization, and in particular after the current coronavirus pandemic started in 2020. First of all, they asked to industrial companies if they think their operation technology cybersecurity's priorities has changed after the pandemic started, and 46% of the companies said that probably yes. And even more, Kaspersky reported that the number of phishing cyber attacks went up since March 2020. It is still early to determine the reasons of this, but Kaspersky and some publications states that this can be due that the people that wasn't prepared or haven't received any information to work remotely is starting to do so, and in many times with their own equipments. So the surface of attacks has increased, and in general, the number of vulnerabilities, because in many times the personal equipments of the employees of a company are not properly prepared to perform teleworking in a secure way. They, for example, in many times they do have antivirus, firewalls, or even more, the employees could make mistake, like, for example, decide to work remotely from a public network, like in a Starbucks coffee. So it is important that employees should be frequently trained to perform this kind of remote work, and the technology has to change to meet the security requirements of this extreme situation. Another insight that this report of Kaspersky presents is what are the main cybersecurity challenges considered by the companies. First of all, 32% of the company answered that the injury or death of employees. Another common answer was the damage of their product and service quality, the loss of proprietary and confidential information, and the cost of the incident response and mitigation. So now we can see that cybersecurity is not only a big priority now more than ever, but also that is closely related with the safety of the employees, the quality of the products and services offered by a company, the loss of confidential information, and even more that the incident response is a big challenge and is very important, because it can mean cost in terms of loss of the customer confidence and in general the quality of the products and services offered. And the main way to actually have a quick incident response is to perform a proper security monitoring of the systems. Finally, Kaspersky asked to the companies what they consider are the technical trends that have a stronger impact in their cybersecurity. Many of them answered that the use of industrial IoT components, the adoption of cloud and software as a service technologies, the use of machine learning and in general artificial intelligence technologies, and the adoption of 5G communication networks. So as we know, new technologies necessarily come with new vulnerabilities, and this impacts the cybersecurity. So to summarize, why is important to perform monitoring security? Because as the last three presentations said, there is an important increase of the amount of vulnerabilities, and Kaspersky has also reported that their severity is increasing too. Then because companies, industry is adopting new technologies, and this comes with new vulnerabilities. And finally, because the reaction time is crucial in these cases. So let's see what is actually security monitoring. But first of all, I would like to present you these three basic concepts of cybersecurity. A vulnerability, which is a weakness that can be exploited by cyber criminals. This vulnerability is not actually making any damage in a system, but if it is exploited or leveraged by a malicious actor or by accident, it can actually make a damage. This is a threat. A threat is actually the exploitation of the use of this vulnerability to cause a damage in the system. Both vulnerabilities and threats can be introduced by accidents or on purpose by a cyber criminal. Finally, a cyber attack, which is obviously always made on purpose, is any offensive maneuver that targets damage a computer information system, a computer network, an infrastructure, etc. And in general, cyber attacks violate completely or partially one of the three principles of the cybersecurity. The availability of the system, that means that it is able to serve its purpose and that its information, its data, is always available for the users. For example, a denial of service attacks impacts the availability of a system because the legal users cannot access to it anymore. The confidentiality, which is the property that the information must not be available or disclosed by unauthorized individuals, and the integrity, that is the property that say that data cannot be modified by unauthorized actors. So what is security monitoring? Is the fact of observing or inspecting a network system, application, a network system or application at different points in order to detect malicious activity or policy violations. In general, one of the most basic tools to perform security monitoring is an intrusion detection systems. And these tools follows mainly two approaches. They are signature-based or anomaly-based. Let's see in detail these two approaches. Signature-based intrusion detection systems, they monitor events in a system and compares them with patterns or signatures that describe good properties, good security properties that must be respected, or attacks and threats that we want to avoid. Important to say that this information is saved in a database. So to perform signature-based intrusion detection, we must first of all create a database with the patterns and the signatures we want to monitor in the system. These signatures are security properties or rules. And as I say, they can describe good behaviors. And in this case, the non-respect of the security properties would mean an abnormal behavior and potentially an attack or a threat into the system. For example, the access of a specific service must always be preceded by an authentication phase. Or on the other hand, the security property can describe a malicious behavior, that can be an attack, a threat, or in general a misbehavior. And in this case, the respect of these security properties will trigger an alert. For example, a big number of requests from the same user in a limited period of time can be considered as a potential denial of service attack. The main advantages of the signature-based intrusion detection systems are that once they are installed, they can perform very quick detection. And in general, you install them and they are ready to be used. They don't need a learning phase to learn the behavior of the system. The disadvantages are that a simple modification of an attack could make it undetectable. And more complex the rules, more demands we will have in terms of processing. And also that in general, as the rules try to be as general as possible, the signature-based intrusion detection system can generate a lot of false positives. One of the main challenges of to this approach is, in the case of monitoring security in networks specifically, is how to identify attacks that span across several packets, and how we can identify attacks or misbehaviors by preserving at the same time the privacy of the user. Some example of IDS, in this case only for networks, are the open source solutions called Snort, Suricata, or SIG, before called Bro. And in Montimash, we also have our IDS called Montimash monitoring tool that I guess many of you know already. The other approach, it's called anomaly detection. In this case, the IDS will have to have a learning phase where it will learn the normal model of the system, and then when in the monitoring phase, any substantial deviation of this defined normal model will be considered as an anomaly that can be translated to a potential intrusion or attack into the system. As I said, we need to learn the normal model of the system. A very common technique using in this kind of IDS are, of course, machine learning and, in general, artificial intelligence techniques, but also another statistical based or knowledge-based methods are used. In the advantage of this approach, we have that we can detect new attacks, as the only information we need is actually the normal behavior of the system, and also we can help we can use anomaly detection to help a rule-based IDS to reduce the rates of its false positive. Between the disadvantages are that it's in general less accurate than a signature-based intrusion detection system, where we actually have defined it very detailed the misbehavior we want to detect. In the challenges, and these challenges are more related with the machine learning anomaly detection, is first of all, as in all machine learning applications, we need data, good data, and lots of it to be able to learn properly the good behavior of the system. Also, in general, we need to make the good choice related with our case study of the algorithms that we're going to use. And in general, we need to be able to generalize our model to make it applicable to different use cases and avoid what is called overfitting in machine learning. What we're going to do actually in VeriDevOps is, first, we're going to study how to include the security in the DevOps process, how to go from a raw requirement to a formalized security requirement by using NLP techniques, as exposed in the last two presentations, to transform these formalized security requirements in a security property that we actually can use to perform rule-based and anomaly-based monitoring of the system. So this is basically the methodology, the framework we're going to be using in Montimash in the case of the VeriDevOps projects. We're going to take traces, that this can be application logs or network traces of our use case studies provider. We're going to extract from their logs important relevant events or features that we're going to use to perform rule-based monitoring, machine learning-based anomaly detection, and another technique we call root cause analysis that allow us to when an incident happens to determine its potential origin. And finally, we're going to take all these results and make interesting, relevant plots and charts to inform the relevant people when an incident occurs, and in general, the current status of the network or the application that we were studying. A short example of what we're doing is the AVV case study, where we have to identify if the measurements performed by certain sensors are valid or not. To do this, we will perform monitoring. And some interesting research question we're studying in this case study is how can we improve security and safety of an industrial system by doing the security monitoring techniques I just presented to you. Also, how reliable is the use of machine learning in industry compared with the algorithm that they already have implemented. In the case of AVV case study, we're using machine learning, we're using a multi-layer perceptor classifier to classify the measures made by a sensor into valid or invalid. We're using certain features that are very specific of the case study. And the dataset we're using is a dataset provided at AVV that we split, I think in the proportion 75% and 25% to perform the training phase and the testing phase. And as you can see, we're obtaining very interesting results in terms of accuracy, recall, and precision of the classification. This is still work in progress, and as I said, one of the main challenges of us in this moment is to be able to generalize enough this model to avoid overfitting. Finally, I would like to present you what is my thesis. It is called Security Testing and Monitoring of Cloud-Native 5G Networks. It is supervised by Professor Anne Cavalli of IP Paris, but Fatia Saidi of Université Paris-Saclay, and Louis Manuli of Montimash. In my thesis, I will perform mainly, basically the same methodology I just presented to you for monitoring for VeriDevOps, but not in industrial control system, but in 5G networks. So the idea here in general, we will have three main stages of the thesis. First of all, to perform a penetration testing to propose some kind of attacks into the properties of 5G networks. For this in Montimash, we have developed an open source tool called 5G Replay that you can check on GitHub that allows us to perform fuzzing testing into 5G networks. And then the idea is to perform the same monitoring techniques I just presented to you to be able to detect the attacks proposed in the previous stage, and finally propose some countermeasures for these attacks. These are the references I used to prepare this presentation, and thank you all for your attention. I will be happy to answer your question.
Okay, thank you very much, Johanny. So very interesting, very informative presentation. Any questions from the audience? So otherwise, I have some small questions. So you had slide 15, and you mentioned properties and resources. Do you need any specific like formal model for resources? I mean, to make your properties working. All right, so you're checking monitoring techniques working. So I think it was kind of an example that you mentioned that some resources should be available after authentication. What kind of do you need a resource model for that, or kind of what kind of things you need as a kind of input for your monitoring tool in terms of system description?
I think in monitoring in general, we don't work by assuming we know the system. What we need to actually know is the security requirements we want to achieve, we want to meet. So what we actually will need is very clear security requirements. Like, for example, the two examples I have here, like in our system, for example, AVV systems, we're interested in monitor if each access to our services are always preset by an authentication phase. What we need is that statement, the security requirement, or an attack that we want to avoid. We in Fagor case study, for example, were very interested in detect potential denial of services attacks in this server.
Okay. Okay, thank you. Any other questions from the audience?
I have one question. It's on the slide where Johanny presented this a case study with ABB. You mentioned this solver. This I think it was abbreviation of something. I was wondering what was this? This on this hidden under this hidden layer, this IBFGS solver.
These are parameters of the classifier. In this moment, I'm not able to give you details about it.
And then how do you deal with this imbalance classification? Because I think you have lots of valid, but not many invalid.
Yeah, that was a big problem. Well, it's still a challenge because we have exactly in the traces provided by AVV, there are lots of valid measurements, but very few number of invalid measurements. In this case, what I did was to combine data sets and then shuffle them. And in that case, I had the same amount of bad cases, invalid measurements, and valid measurements. And then the features I took, they are not related with the configuration of the system. In that case, to be able to combine the data sets. Because of course, if we are combining data sets and at the same time we are using features that depends on the system, the implementation doesn't have many sense. But again, this is a still work in progress. We need to, and we're getting very good results, both by checking it in the data set divided. The idea will be also to have very good results by checking this in a completely new data sets. And well, this is still work in progress.
Okay, thank you.
Right. Okay. Any more questions? Anyone? No comments? Okay, then, Zohani, thank you very much for this nice presentation. So I guess in our agenda we have a small break. Let's take about 10 minutes, and then we will come back with more presentations, and it will be the turn from the OBA Academy to present the work. So we will ask Gadha to talk about the metamorphic testing approach. Right, so let's take 10 minutes, okay? And we at 11:23, let's say, European time, okay? Okay, should be going back. Right, Gadha, are you here?
Yes, I'm here.
Hi, hello. Yeah, you can share your screen.
Sure.
Mhm. Okay. Okay, I believe we can start.
Yes, we can
Mhm.
start. Hello, everyone. Good afternoon. I'm Gatha. I'm a research student at Ubo Academy University. I'm from India and currently living in Finland. And I have completed my master's this summer and now in the first phase of my research studies. And I'm working on a tool to develop a tool-based approach for automation of metamorphic testing. The motivation for the research is aligned with the goals of the VeriDevOps project. We need improved verification and validation mechanism for software systems. And for this, to develop tools for functional and non-functional testing of industrial control systems, and to a possible extent implement automation of these testing techniques for verification of security requirements. In recent times, we hear reports about cyber attacks on software systems. And to avoid such security vulnerability exploitations, we should adopt smarter testing techniques. And well, the challenge here is to the complexity of the large scale industrial systems. And we are often limited by the effectiveness of the testing techniques and problems such as test oracle problem. And a solution for this test oracle problem is metamorphic testing. In metamorphic testing, in this approach, we execute the system with different set of inputs, and we formulate metamorphic relations which are identified from the software specification. And then we compare the output of these different executions with different set of inputs and derive, test the system to detect any anomalies or possible defects. Metamorphic testing has already been applied to test specific problem domains. And among the most popular ones are to test web services and applications, computer graphics, simulation and modeling, and embedded system. One example from a case study or research is that we can also use metamorphic testing to enhance security testing. And where we are facing the test oracle problem, and we can use this to detect web failures. And metamorphic testing also enables negative testing of security related functionality. And we can derive metamorphic relations from security requirements and use it for security testing. So an example would be detecting a login failure in an internet banking website. So in this case, a simple metamorphic relation is used to test when different users log on to a local computer using different usernames. They should always be able to follow the same steps to navigate to the website and click on the internet banking login button. So here you can see that when they tested, they detected a failure. When they used a different user account, they did not get the same web internet banking login page. And currently there are techniques or approaches to systematically create metamorphic relations. And one such approach is to combine the existing metamorphic relations and form a new metamorphic relation which can be used for testing, and this approach would reduce the testing effort and time. And there are machine learning based methods and methods to automatically infer polynomial metamorphic relations using a tool known as metamorphic relation inferer. And as per a recent survey on metamorphic testing, the tools that are available currently are both Java-based tools. One is JFuzz for the unit testing of Java classes, and the other one is also based on Java modeling language runtime assertion checking. So in our case study, we are dealing with the position control system to determine the position of the load using positional markers. So this system receives as input data coordinates from a camera module. And these input comprises of points that are corresponding to positional markers. And it could also have noise in the frame corresponding to reflections from the environment. And system would generate an output indicating if the actual markers are identified or not. So in the metamorphic testing approach, we are generating a source test case based on the input that we received from our industrial partner as a data log. So this input is a positive test case where it contains only the actual positional marker coordinates. So in that case, the system would generate an output which is like true for all the input records in the log. And in our approach, we create an input which comprise of the actual markers and noise, which are generated in a semi-random way as an invalid input to the system. So we are trying to fuzz the system for negative testing. And in case of the input that we created, we expect that the system shall identify the positional markers correctly. And the metamorphic relation that is formulated is that the output of the first execution and the next execution should be identical. Based on the initial results that we get, it indicates that the metamorphic relation is violated, and it could possibly reveal a defect that the system is failing to identify the valid patterns and the noise. So the advantages of this testing approach is that this enables a feedback-based program evolution, and it could also help the industrial partners for their future regression testing of the system. And currently, the research challenges in metamorphic testing are to develop strategies for generating good metamorphic relations, and to apply the prioritization and minimization to reduce the number of metamorphic relations that are identified, to end up with good ones to enable effective testing. And also there is a need to create automated test generation and test execution approaches. And currently in public domain, there are very less metamorphic testing tools that are available for the researchers. So this is the research plan for my research studies, and I have referenced the following materials. Thank you. I'm not able to hear you.
We can hear you. Yes.
Yeah.
So I guess if there are any questions.
I have a question. In the example that you have done, provide, You mentioned that you have defined a metamorphic relation that doesn't work for the markers. How do you plan to modify in order to obtain a correct metamorphic relation?
We formulated a metamorphic relation, and when the metamorphic relation is violated, we end up with a test verdict that the system failed to satisfy that metamorphic relation. So the metamorphic relation that we formulated is based on the specification. The system is supposed to identify the valid markers in all cases. The system should ignore the noise. So the metamorphic relation is based on the specification, but in the test execution, it violated the metamorphic relation. And that is what is revealing the fault in the system. I hope I...
Yeah, okay, thank you.
Yeah. Thank you.
I have a question too. Maybe it's very basic, but what do you think is the difference between the metamorphic testing and the fuzzing testing?
The only difference is that metamorphic testing uses these metamorphic relations, and it is kind of an it enables the negative testing. And to decide the test verdict, we are using this metamorphic relation. Whereas in fuzz testing, it is just fuzzing with invalid inputs. There's no concept of metamorphic relation or a violation of a metamorphic relation to prove the test or to predict the test result.
Okay, thanks.
Thank you.
I can add a bit more here that in this approach that we use sort of fuzzy testing to check the metamorphic relationship, but it's not mandatory, or this is not the only way to check the metamorphic relationship. So there can be other ways to check the metamorphic relationship. In that, so the metamorphic testing, we are mainly concerned about the relation that it should satisfy, and then how we generate the follow-up test cases, it's up to the tester or the developer that how he came up with the follow-up test cases. So it's not that we are restricted only to fuzzy.
Thank you.
Andre, we cannot hear you.
Hello, do you hear me? Hello?
Yes.
Yes.
Yes. Yeah, I still have a naive question about this metamorphic relations. So can you give a naive example to me about what it is? So is it something if, for example, this holds for one example, it should hold for all like typical examples? So what it is?
If you want, I can give you an example.
Yes.
So let's say you are booking a hotel, or you are looking for hotels to book in France, and you go to booking.com and you search for all the hotels in France, and you get a list of hotels. And then you are searching also for all the hotels in Paris, and you get a list of hotels from Paris. And the metamorphic relation here is that the hotels in Paris should be included, all of them, in the hotels in France. Okay. Otherwise something is wrong. And for instance, there has been an example at I think at Spotify, where they were searching for certain criteria within the music database, and they would get a list.
Mhm.
And if they would search for the same criteria, but they ordered the list differently, or they asked for the results differently in a different order, then the list was different, which means that simply by sorting, the results were different than the original one. So that was a metamorphic relation. I mean, when you search for the same results, regardless if they are in which order they are, the two results should be identical.
I see. Okay. So it's trying to guess the category for a kind of a set of queries. Okay. So to keep this kind of logical relationships.
Yeah, it's just a logical relationship between the outputs.
Okay. Thank you. Okay. And any more questions from the audience? So okay. Then we will switch to more presentations, and so our next presenter will be Ivan Fia from ABA Academy. Yep. Ivan Fia, you can join and share.
Hi, can you hear me?
Yes, we can hear you.
Okay, then I'm gonna share my screen. Okay, now you should be able to see my screen.
Okay, thank you.
So my name is Ivan Fia. I'm a master's student at ABA Academy University. And my master's thesis work concerns web client test transfer. So I will get right into it. So basically my work concerns testing of graphical user interfaces, and such testing can be manual or automatic. And automated testing is defined for the purposes of my work is the one that emulates human interaction with a system under test. Nevertheless, there is also manual testing, and although it's very costly and time-consuming and labor-intensive, it's still widely used. According to research literature, it is sometimes even the preferred option due to very high maintenance effort associated with automated testing. So there are certain challenges of automated graphical user interface and testing that basically, because of those challenges, we still have manual testing. Basically, when our system changes, very often test execution breaks. And according to research, one of the most common causes for such failure is basically that it's impossible to locate graphical user interface widgets, maybe because their locators changed, for example. Research suggests that more robust identification of graphical user interface widgets could basically tackle this challenge of automated testing. There are other challenges associated with automated testing. For example, if we use crawling of graphical user interfaces, it's very time-consuming, it's very slow, and such tests also lack context-aware inputs. So they basically do not necessarily emulate human interaction very well. So there has been a very recent proposed solution, which is called semantic mapping or matching, depending, like it's the same thing in the literature. And this idea was first proposed, as far as I know, in 2018. And the idea is that if we have applications, let's say in the same domain, such applications often have similar functionality. And since they have similar functionality, their user interfaces can be quite similar, although they might be perhaps using different text attributes to signify the same elements, but they nevertheless perform the same function. Like, for example, in this kind of draw an example, we have two authentication forms, and they perhaps might have different names, use different labels, but they nevertheless perform the same thing. So the research in this area has been mostly developed for web applications and mobile applications. And the idea has been that we can harness information from neighboring elements to identify corresponding web user elements between different applications. So the research suggests it can be done between applications in the same domain. But nevertheless, in my case, I'm working on test transfer between different versions of the same application, meaning that when system is updated and our locators perhaps changed, we still can perform testing without test execution failing due to changes. So how exactly can it be done? So basically, my task of test transferring can be broken down into several steps. So the first step being is once we have, so it's done using basically Selenium WebDriver. So once we have a web application in Selenium WebDriver, what is done first is that this is like the solution parses HTML, and it extracts all graphical user elements XPath and their corresponding attributes. So for example, such attributes could be text, IDs, values, their position, and for example, for images, there could be alternative text. The next step is embedding such attributes for further clustering. So I use deep embedding. I use one of the BERT models for it called as BERT. So I treat such embeddings as sentence level embeddings. And after that, I apply a semi-supervised clustering technique. I have tested quite a lot of them, but one of them is like k-means and self-organizing maps and also label propagation. And the next step in the test transfer procedure is actually finding matching graphical user interface widgets for test transfer. So once we have deep embedded text-based attributes, we match them against clusters in another version and find the one with the highest cosine similarity score. So the way it works as follows. So first of all, let's say we have a web page, and using Selenium, we extract attributes which are then needed for embeddings. Such attributes are concatenated and embedded using BERT, which is sentence level BERT. Then these embeddings are fed into a semi-supervised self-organizing map, and clusters are obtained. And I have to point out that each cluster contains only one widget. So there are at least as many clusters as there are widgets on the page. So cosine similarity here is actually like similarity between two vectors. So we use here sentence level vectors. So these are not word and not document, but on this level it's sentence. So then again, we also need to find like corresponding pages between different versions. Since here again, I use cosine similarity. So I use document level embeddings, and then I find the matching ones with the highest cosine similarity score. So once corresponding screens are found, their clusters are compared, and the ones with the highest similarity are matched. So I think I have here a small, quite like work in the progress example, but this is how it would look like. So once we have, like we find corresponding pages, and now we have to find corresponding clusters that contain our widgets. So We compare them, and the system finds the one with the highest cosine similarity score. As I have already mentioned, each cluster contains only one widget, which is an interactable element. So for example, a link, an input form, a button. And testing is implemented in Python using Selenium. And once we find corresponding cluster, we use existing test for our graphical user interface widget. So basically we use for locating widgets, we use absolute XPaths. So how would I evaluate this technique? So in research literature, so far accuracy has been the most popular metric for evaluating this. So we would, for example, we would know basically the correct corresponding web user interface elements, and we can compare whether like the proposed solution will actually find those corresponding elements or not. Also, precision and recall have been used, but in my master thesis, I have had to compare basically many models for many steps. So for example, for including like the clustering step. So for evaluating the proposed solution, I also will evaluate different clustering techniques and different parameters for these techniques to find the one which is the most appropriate, though of course it is very hard to say what would be the most appropriate. Also, multiple BERT models are evaluated for embeddings. There exist a lot of BERT models which are pre-trained language models. And they of course also produce different results. Yeah, so the next page is the references. There have been lots of challenges in my work, and it is not yet done. One of the challenges has been with the clustering, because first I treated this grouping of web elements task as a supervised problem. So I tried to find some data which I could use to train a model that would, for example, classify web elements into different groups related to their function. But unfortunately, it's quite hard to obtain such like public data that wouldn't have any like copyright issues with it. Another issue, of course, is it's hard to test such technique without having some industry available applications that could be basically used for testing. So I'm quite limited to like public options, whatever is in public domain. Yeah, so these have been some challenges and issues along the way, but like the existing research shows that the whole idea of test transfer is quite promising, although it has been done on mobile applications for the most part so far, but it seems to suggest that it saves a lot of time basically in testing, and produces more context-aware inputs for testing because they are not random. Yeah, so this is a promising area of research. And these are some of the references I used in my presentation.
Okay, thank you very much. Very interesting, very surprising techniques for using NLP for testing. Any questions from the audience? So otherwise, I have a question from my side. I noticed like sentence extraction. So especially in the example, the sentences are kind of a number of labels, not kind of full sentences, right? So if you can back to the example, please.
Yeah, yeah. I mean, it's a kind of like working. It's an example from my demo, so I doubt it's going to be.
Oh, it's interesting.
Yeah,
It's
so,
interesting.
yeah. These are labels, and they are concatenated. But I treat them as sentence level embeddings. And why I do that is that there actually has been a very recent study, like I think published like a month ago, which compares different embeddings for the task of task transfer for this semantic matching. And they compared, for example, word2vec, which is like word level embeddings, with contextualized embeddings. And what they found is that document and sentence level embeddings are more precise for this task than word level embeddings. Because because there were several techniques proposed in this area of semantic matching, and they use different word representations. Most of them use word2vec actually, because at the time when this research originated in 2018, that's what still was used. But I think by this time, BERT basically kind of is the most state-of-the-art solution we have in natural language processing as a pre-trained solution. So yeah, so this is why I use this. Of course, the risk would be one way to maybe compare word2vec to maybe like word level embeddings to sentence level. And see what would produce, but this is what like the current research suggests so far.
Okay, interesting. Also, in terms of example here, how you would interpret the various numbers for Cassine similarity here, like an example number 89. So it seems the Cassine is 62% or something, and then seems to be similar. So. And then we have like Cassine similarity 9 when there is username mentioned, so it should be somehow very close. So how would you compare those?
Well, basically,
Cassine function.
Yeah. Well, basically, cosine similarity works in a way that the more similar the vectors are, the higher it is. So it's the interval. Normally it's like between -1 and 1, so closer to 1, the more similar it is. But I think that many proposed solutions, they use a certain kind of threshold. But they don't all use cosine similarity. They also, some of them use like Levenshtein distance, for example. So this is another thing that I consider too, because I have been also trying different kind of measures of similarity to include in my thesis, this kind of comparison to find which one is the best. But in most of the cases, cosine similarity is used, and it's quite easy. As a metric, it's very easy, it's very understandable for humans, and because it just represents similarity between vectors. So
how would you interpret that? Which are the similar, given this example, which are the similar ones and which are
less similar, dissimilar? Yeah, well, we actually can see that the very last one, it's obviously perhaps certain that shouldn't be there. It has number 1, so it's the same. And the most dissimilar one, I guess it's this 176. It's this welcome back, and then completely unrelated. So we can see they are not very related, really. But I would still, yeah. So perhaps there should be certain threshold above which we should consider that something is similar and something is less similar. But I think it's quite hard to work out this threshold in reality. Yeah, but I guess there should be certain something. Yeah, but we can find, for example, example 104 with cosine similarity 0.59. And it corresponds, for example, if you're not registered, please continue by, I think, creating an account, and the other no account, join us, which are essentially the same things. What it suggests to the user is that they don't have an account, then they need to continue by creating one, right? So although we can see here that absolutely different words are used to describe the same thing, The cosine similarity works quite well here. Embeddings work quite well here because it still finds those as having the highest cosine similarity.
Okay, thank you very much. Thank you. Very interesting example. Any more questions from the audience, please? So in this case, thank you very much. A very interesting presentation. We'll have another presentation on clustering by Nikita at the end of this session. Now we switch to Milad Dalen, and Mikhail would present his ideas and his research on test automation frameworks. Mikhail, you may share your screen.
Hello, yes, let me just share my screen. Can you see my presentation?
We can see your screen. Probably you have the double screen. We have not. This is presentation. Yeah, now we see it.
Now you can see it. Okay. Let me just sort it.
And we have presenter mode, no, display settings. If you go display settings, display settings. And switch the active screen. Yes. Or swap presenter. Yes.
Yes. Okay. Okay. Hello, everyone. I'm Mikhail Ibrahim Salari from Milad Dalen University. In this short presentation, I want to talk about what I did to the moment and what is our future work. So the title of my presentation is towards the use of automated test generation for finding faults and vulnerabilities in industrial PLC software. Here is some information, personal information about me. My name is obviously Mikhail Ibrahim Salari. I'm 29 years old and I'm from Iran. And my city name is Mashhad. If I want to give you some information about my education, I have a Master of Science in Information Technology Engineering, Computer Networks. And the title of my master thesis is Android malware detection using ensemble classification and sample clustering. I also hold a BSc in Computer Software Engineering from Islamic Azad University of Mashhad, and I also have a high school diploma in mathematics. My research experience is more about computer networks, especially Internet of Things, industrial Internet of Things, and software-defined networking. I also have some background in the field of network security, software security, and software testing, automated test case generation. I also have some background that are related to my master thesis about malware detection and ensemble classification and data mining, especially clustering sampling techniques like K-means and X-means. My work experience is more tied with IT support in several internet service providers in Iran, my country, including Mobinet, Asiatek, Khorasan Telecommunication Company, and so on. I also have some background in about being an IT specialist in Asanwat Razavi Corporation and Jafar Jam corporations in my country, and I was also an expert in economic affairs in receiving claims section of Mashhad municipality. Let's start by giving some information to you about my PhD studies. I started my PhD studies about 8 months ago in April, and I'm a member of VeriDevOps project. My research focus is about test automation and industrial software security, and I'm proud to have my supervisors as Dr. Edward Kyle Enoyo as my main supervisor, and also Christian and Vasif as my co-supervisors. My main research question in my PhD studies is how to bring effective automated test generation and execution to industrial PLC software for finding faults and vulnerabilities. Right now, we are working on a comparative study on test automation frameworks for PLC systems in Codesys IDE. And actually, we use a hybrid methodology in this study. We use a combination of Gray literature review and industrial case study. In this study, and also on the whole, we are more focused on Codesys IDE because of several reasons. The first reason is the Codesys IDE is free. It is PLC manufacturer independent IDE, so every PLC vendor can use this actually IDE to develop their code. It is widely used in industry, and it supports all programming languages of IEC 61131 standard, including function block diagram, structured text, CFC, ladder, and SFC. And one of the VeriDevOps industry partners, ABB, is also using this IDE to develop their codes. In this paper, we actually detected some important features to be considered when we want to make the comparison between the test automation tools of Codesys, and we categorize them based on several categories like the company constraints, such as cost, supported platforms, and easy to installation, and also maturity of the tool, like the industrial use or a stage of development. We have some other categories in our paper, like testing functionalities, tool flexibility, and usability. Here's a bigger picture of our hybrid methodology in this comparison paper. It will start by the one on the top. You can see that we have the Codesys IDE. It is our focus IDE. Then we perform a GLR, a Gray literature review, to detect the test automation tools of Codesys. And by this, we want to consider the industry practitioners' point of view, which is usually published online in forums and other online discussion rooms. So after detecting the test automation tools of Codesys through GLR, we actually did a literature review to detect the important features of these test automation tools to be considered and to be considered to make the comparison. And after detecting these features and citing the source of extraction, we just evaluated them by asking the engineers of ABB automation company to validate the important tests. And after gathering the final list of the important features, we conducted the tool comparison between these tools. And finally, we evaluated the functionality of these tools by applying them on an industrial case study that is provided to us by a famous automation company, which is ABB, automation company of Sweden. And finally, we have the automated test and the results in the paper. And actually, after finishing this work, which is in the, I can say, in the final state, then we have a future work, which is ongoing actually right now. And we want to create the first search-based Codesys compatible automated test case generator for PLC programs. So we want to detect the fault and vulnerabilities of developed PLC programs using an automated approach based on the Penguin test automated test case generator. Penguin is the first, and I can say is the only actually Python-based automated test case generator for regular Python programs, but we want to actually apply it on PLC programs to detect, to generate automated effective test cases for PLC programs. Here's a bigger picture of what we want to do. In the first step, we have a FPD program, which is usually in the XML extension. Then we want to first manually and then automatically generate a Python file based on that XML program. We want to convert the PLC program to a Python file, and after that, we want to feed it to Penguin to automatically generate test cases for it. After having the test cases, we will actually feed it to codices and automatically generate the required test cases. And as you might know, in XML file, we have inputs, outputs, and tags, which should be mapped to a Python code in a proper way. And it is another contribution of our future work. Thank you for your time, and I'm available for any possible questions.
Okay, thank you, Mikhail. Yeah, I just wondering. So at some point you talked about comparing various frameworks for test automation, right?
Yeah.
And so you can. Yeah, I saw a number of features, right?
Yes.
So what's conclusion of this part of your study? So.
Actually, in this study, we wanted to, first of all, discover the most discussed test automation tools of codices based on considering the practitioners' point of view, the industry practitioners, because they are playing the main role in this area. And after that, we try to propose them and also compare the features and limitations of available test automation frameworks of codices. So we actually extracted the important features using a literature review on the related works, and then we validated these features using the help of ABB. We asked them to validate the important features from their point of view. And after making this comparison on the codices test automation tools and introducing their features and their limitations, we evaluated their applicability on a real-world industry case study by applying them on a crane supervision PLC program of ABB.
Yeah. Did you compare several, let's say, frameworks, and so
Yes,
you choose the
actually,
best one?
no,
what's the
actually,
conclusion?
the test frameworks that we detected through GLR, performing the Gray literature review, the test automation frameworks are Codices Test Manager and also CO Unit. These are the most discussed and also most famous and reliable test automation of Codices ID, and both tools are actually verified by Codices ID. So these two test automation tools are the test automation tools that we are focused on in this paper.
Mm-hmm. And okay, and so based on this information, what's your let's say conclusions or take away? So using that, you would use that for development of your framework. So how would you use this information from the study?
Actually, it is the first step of my study to first discover these test automation tools.
Mm-hmm.
And in our future work, when we want to actually develop a Python-based automated test generator for PLC programs. In the final step, when we generated the test cases for FPD programs, we can use this actually test automation tools to automatically execute these test cases on the FPD program in Codices ID. So that would be the use case of this study in our the next study, actually, in our future.
Okay, thank you. Any questions from the audience? I have probably one last question. So you mentioned this translation to Python from PLC code, right? So, but what I understand you meant is this: you have this functional block diagrams, right?
Yes.
That you somehow translate to Python. How it is done? Because I think this is kind of one of the most important steps in your framework.
Yes, that's a really good question. Actually, this study is just a concept, and we just started thinking about it. So it is in initial states, but actually the FBD programs can be exported as an XML file, and we have to actually analyze the different parts of an XML file to be able to efficiently convert them to a Python code. For example, in an XML file, we have different sections like the inputs and their values, outputs, tags, and other information. So the first step for us would be to have a good interpretation of a XML file and its in different actually parts. Then we can actually develop a Python code to automatically fetch this kind of features and also this kind of information, and then transform them to a Python code. So this would be our first challenge, and I hope with analyzing these XML files, we can actually achieve this important transformation. Yeah.
Okay. Thank you. Any questions from the audience or comments? Okay, Mikhail, thank you very much. Very interesting. I think we'll be all interested to know results of your work in the future. So our next presenter would be Damir. Damir, are you ready?
Yes. Yes, I am. Let me just try to share my screen.
Okay.
Just a moment. Let's see. Can you just share the PowerPoint? Okay. Do you see the?
Yes, yes, we can see that.
Okay, it's full screen, right?
Right.
Yes. Okay, perfect. So, hello everyone. I am Damir Bilic, PhD student at Meladalin University, and maybe I can do this as well so people can see me. Yeah. Hello. I am Damir Bilic, a PhD student at Meladalin University, and my research is mainly focused on, well, my PhD thesis is kind of around product line engineering, and the current study that would be quite interesting for VeriDevOps is about system evolution, I think, at least, is about system evolution in product lines. So first, a small introduction what product lines are. So in product lines, the idea is basically to not build, like if you have, a family of similar products, like for example, like an example from a previous project is this heavy machinery like excavators, haulers and different machines, where you have a bunch of similar machines that are built at one company in the same premises and so on. So, you don't want to build each of them individually, but the idea is to, build them by using reusable assets. So, and the idea in product line is that, you have a bunch of reusable assets that you can just put together to build, to get any product that you want. So, and then you get, just a feature selector where you have options that you can change. So like we can change the propulsion and we can change the attachment. And then like if you do this, then like the wheels change to, the crawlers change to wheels, and I don't know, that we can get like a demolition hand instead of a bucket. And also, that also has to be specified in requirements. So if you like look up here, these things are changing depending what options you have. So that's kind of the idea behind product lines, basically to build products by kind of building for reuse and then just configuring the final applications instead of building one by one. And then also an illustration here is or this is kind of the main principles in product lines, is that you have a variability model, often a feature model, which describes the variable parts of the system. Like we have, I don't know, feature A and B here and some constraints between them. And then you have the system itself in the solution domain, where you have, a core which is same for all systems, and then, a mapping between kind of the description of the features and their implementation. And then the idea is that you just pick something here, and then it automatically generates the final system. So you don't have to do kind of anything in between, but, just developing these big reusable assets, which is not easy. But anyway, so that's the idea behind product lines. But now the challenge is about the evolution of these systems. And there are two options on kind of main options how we can evolve these systems. And so, and let's go through both of them here. So you start with the product line. So you have a core and you have some, you know, reusable features that you can put on the core, and then they can be configured in different ways. And then one option, when you need a product that does not exist in the product line, you can either make it by changing the product line. So for example, you need, let's say you need this variant B, and like variant B has this green part which does not exist in the product line. So what you can do is you can change the product line, you know, add the green part, and then you can generate variant B, and then you see like it has the core which has changed, and then it has two features. So that's one option, and that's kind of the ideal option. Another option is to, you know, you need maybe variant A 1.1, like with, you know, stuff that has some more, like some stuff that has changed. So instead of changing it in the product line, you change it, you get the closest possible system variant that you can get to the one that you need. And then you change it, you know, just that single product without, you know, changing a bunch of like, or without changing the reusable assets that can affect many products. You just change one, so then you don't have to worry about affecting all the others products once you make the change. And this second approach, where you just change, kind of you get one variant and then you just change it instead of the product line, is, at least like from our discussions with different industries and also reading the literature, is the most common approach used. But once you change a variant here, it kind of gets detached from the product line, because, you know, there is no mapping between these features and they have changed. So, you know, how do you handle that? And then the idea is to make these things, again, reusable. You have to merge it back into the product line. But the question is, how do you merge it? Because if the same thing changes here and here, you get merge conflicts, you know, and how do you resolve them? Well, you resolve them by doing a lot of manual analysis, and that's it. But still, merging them, you know, takes a lot of effort. And the thing is that the changes you make here, you know, might make it impossible to merge it. So if you know, do something that will violate some other features, then you don't really want to merge it back, because you kind of lose the variability space, or you might introduce inconsistencies so that you can, you know, generate faulty products, even though the merge is successful. So you can, I don't know, like for example, get, you know, a car without wheels just because you don't have, I don't know, the proper constraint set, or there is like a constraint a conflict or something like that. So the second option is the most common one, but it's also kind of the more problematic one. So what we try in this work is basically trying to address that. And what we do is we have defined a graph, yet another language, a graph which is a feature dependency graph. Basically, we use it to abstract from the system implementation, or any asset of any artifact of the system. Can be a system design or even requirements, or the actual implementation like code or whatever. We generate a dependency graph, so where we abstract artifacts. So either, you know, can be from code, can be classes, or I don't know, from models, can be again classes or blocks or whatever modeling language you use, or it can be even, you know, individual statements, depending which level of detail you want to analyze. And then we basically have two types of relations between the artifacts. It's like containment, so like, you know, one artifact, like, I don't know, an operation is contained within a block or within a class. And then relations, like those can be, I don't know, interfaces between classes, or some kind of relations, or any kind of relations that you want. And then you can give them, you can have more relation types if you want, or you know, you can have you can make these even more concrete if you want. But basically, the artifacts are also mapped to features or the common part. But anyway, we extract these feature dependencies and artifact dependencies, and through them the feature dependencies of the dependencies between these, like what kind of we extract, we take the system and then we get the dependencies between these features and the core, and how they are combined together by using this. Basically, we kind of abstract it through this dependency graph, and this is a snippet from a pick and place unit, which is a benchmark for software evolution, and it's available here. And they provide models, source code, PLC source code, so it's a very, very nice benchmark. So, but what we do, we extract these and then we compare the feature dependency graphs instead of comparing the artifacts at different levels, like, you know, comparing code, comparing the system models. And I mean, comparing them can be quite tricky because comparing these graphical models is always an issue. But, you know, abstracting it to something which is kind of formalized, then it's a bit easier to do it. But we still rely on you know, either the name or an identifier for every artifact to basically to match and compare and find the differences between, you know, the differences between the product line and the variant that has changed and that has been disconnected from the product line. And once we have those, then we can analyze the differences and see how we can combine these. Let's say if you have, I don't know, changes in the product line and changes in the variant, so then we can assess how we can, you know, put them back together while maintaining consistency. So making sure that you cannot really derive any broken systems, like I don't know, like we have. I mean, there are rules. So, like for example, that every, I don't know, attribute needs to have a type or something like that. So you cannot have untyped attributes or some, you know, such consistencies. And then also we maintain the variability space. So we make sure that once the merge is done, it still must be possible to derive, you know, every existing variant from the product line. So yeah, that's what we do. And then we also propose how to change the feature model itself. So like the feature description and the relations between them. So based on these changes, you know, you might add a new feature, maybe an optional, maybe some feature have to change their constraints and so on. So, and this is from a static level. So we just look at, you know, code, like some kind of static analysis. We just look at the code and we look at models and not yet at requirement diagrams. But one aspect that we are interested in is looking into whether the dependencies are equivalent at different abstraction levels when making the system. So, you know, the dependencies between the features and whatever system parts you find in requirement documents, are they equivalent to the dependencies in the system model, or you know, are they even similar? Are they the same, or are they totally different? So what's the difference between them? And then also same with the code. And I mean, it can be, I guess it can be an equivalence question here between the requirement specification and the code. You know, the system model can be omitted if you want. But anyway, so we are interested in checking whether these are equivalent or not, and yeah, and then trying to, you know, make conclusions whether you can predict these the problems, you know, once you do, let's say, once you change the requirements for this new variant to implement these new changes, can you predict that, you know, it will have specific consequences? Because if these are equivalent, you know, at any stage, then you can kind of do it. But if they are not, then it's really hard, and then you have to rely on domain knowledge. So kind of, I guess a question perhaps related to the presentation from Olga and I forgot the other name that was earlier, was how do we extract the dependencies from textual requirements? So maybe I don't know, Andre, if some of the work that you do with machine learning could be used to extract, well, perhaps to map requirements to features, because also the requirements are often not really annotated with feature. Like we have feature information here and here. And I mean, that's needed to have, you know, a function product line, but here it's not always there. So can we kind of map by looking at, I don't know, the previous requirement specifications, can we map the requirements to certain features? And how do we extract the dependencies, saying that, you know, if you have feature A, then feature B also needs to be enabled. So can we, you know, get these dependencies, or can we get these relations between them by looking at the textual requirements? So I guess that's a question for you, Andre, if you think that could be something, you know.
Yeah, so it's definitely not for Rufina and Olga questions. So we have Nikita, who will be presenting after you. He would work on LP subject and on clustering in particular. However, we are not on this kind of level when we define, let's say, relation dependencies. We actually look at similarities of various requirements, but not necessarily on kind of interdependencies. For that, I guess there is a different techniques need to be done. So one maybe kind of as a brainstorming idea. So in RQ code, and what Ildar topic is about, when you have object-oriented requirements, then we actually can add some kind of generalization, interfacing rules among requirements. That's actually maybe something, some source of information for dependencies as a natural code, let's say. So that's going to be much more transparent, let's say, and traceable. Okay. Also, in terms of topic, I mean, in the topic I saw that you will be dealing somehow with CI/CD DevOps thing. So currently, I mean, you meant actually evolution, right? So like how variants can live with product line through evolution. So we will evolve variants and see how this can be merged to the product line.
Yes.
And back and forth. Okay, I see. Okay.
Yeah.
Good. Interesting. So any comments or questions from the audience?
Yeah, so I actually had another, I mean, something else that we also look into is, or that we kind of thought about was the behavior. So I mean, this is it's not a very nice graph, but if you think about this as a state machine, where you have, you know, a state machine of well, it's just one part of this pick and place unit benchmark. So this is one version, this is another version, and to make them a product line, you have to do something like this to support, also basically putting them together to support, basically to still be able to derive both systems at the same time. So I mean to support, you know, to be able to generate this and this, but I mean, this is just a thought. It's nothing that we did work on for now, but we plan to. So can we make sure that, you know, that this actually that is actually true? So like that the properties that we're holding for this system, you know, and this system still hold inside here, and then that you cannot get any unexpected behavior. So can we say that, you know, this state machine implements only these two, so like nothing else? So can we, I mean, the question is, what properties do you check if you do some kind of model checking? And so can we kind of, and I mean, I have no idea about like what kind of properties those could be, but can we extract, you know, properties from here automatically that must hold here, and then also from here, while making sure that, you know, for example, if you look at security requirement, well, I don't know much about, you know, security, but if you have some security requirements, will they be violated once you put these two state machines together? maybe I don't know, because yeah, you get, you know, you might be, because like here you can, if you take this transition, you can avoid kind of this state, or you know, this state or this state, but maybe that's not really allowed from a security perspective. So so can we somehow check these things or not? Yeah, that could be an interesting, you know, once you put them together, or you know, that could be an interesting thing to look into.
Okay. Yeah, I guess some of our techniques should actually deal with this kind of thing. So you of the system and whether the requirements still hold or not. So that's so there's definitely something of interest for the VeriDevOps project. Right.
Yeah. So if someone wants to look at these models, I can. Well, if you just Google XPPU, you will find a GitHub link to this pick and place unit, which is quite interesting. So if somebody wants like these models, there's a bunch of UML models and also PLC code, and like 20 iterations of the PLC code. So I can provide you the link if you want. I think it's also on some slide. Yeah. If you Google this, you will find this a pick and place unit. So yeah, if someone is interested to just, you know, discuss this further, yeah, I'm available.
Okay. Thank you. Any comments, any questions from the audience?
Yes, I have a question about the composition. This last slide.
Yes.
Yeah. What kind of composition rule you have defined?
So I mean, right now, this is like basically we find the differences between them and we just you know, add the differences from one to the other, and we take also, I mean, this we kind of copy the states and the transition from these states, and then we just on the transitions we say that, you know, if feature A is enabled, these transitions are enabled. If feature B is enabled, these transitions are enabled, and the others are kind of disabled, so you cannot get to them. But it's a simple copy and paste as of now.
Yeah.
So,
but apparently, because if you look, you are thinking in doing model checking, you have the same pass in the composite that you can find in the component, no?
Yes, there are.
Then maybe it's possible to conclude that you will find the same properties. Bad news, maybe.
Yeah, it might be. But like another thing is that it would be interesting to simplify these state machines, because, for example, they can be simplified. You can remove this transition, and then you can, you know, get a direct transition down here, because it looking at the system, it doesn't really matter. So if we do that, can we still ensure that the properties hold that we're holding in this? So I guess it would also be another step that we first simplify this, and then we check whether the properties hold.
Okay.
I have a question, Yuri Vain from Obo Academy Group. Maybe first comment. I think maybe you can actually look at these component conjunction operators in multi-view contract theory, because there is a theoretical background how to verify this kind of. It's called actually conjunction of components, and it should satisfy conjunction of the contracts, view contracts, basically. Yeah. This is one comment, and I have also a question. It is about about similarity metrics. What similarity metrics you use when you compare the concepts or features?
Yeah. So right now, right now it's, well, the unique identifier and the relations. So kind of the node in the graph owns the outgoing edges. So it is that kind of the similarity is based on that the unique identifier can be even a name and the structure.
It's basically a structure based similarity.
Yes.
Okay, nothing to do with
Yeah.
ontologies or
No.
Mhm. Okay, thank you.
Okay, thank you. I think we have to move
Thank you.
to our last presentation. Nikita, are you ready?
Yes, sure.
Yes, please share your screen and you can go on with the presentation.
Okay. Can you hear me? Do you see the screen?
Yes, that's fine. Thank you.
Good. So let's start. My name is Nikita Tikhonov. I'm from Innopolis University, and my thesis topic is software security requirements and clustering using deep learning. And so in this presentation, we are going to talk about my motivation, like what is the reason for me to do my project, the problem, like what are the current problems in the field of security requirements and like software requirements in general. We will look at this current state of the art. So I will like gently introduce you into the NLP. After that, we will discuss the plan of my research, and in the end, I will tell you about the evaluation of my of the results. So let's start. As you can see on the slide, there is a graph. There is a plot of the most like the top causes for project failures. And as you can see, if we will look closer, one of the top reasons, actually top two, is inaccurate requirements gathering. So requirements engineering is one of the most important thing if we are talking about project development. And in particular, if we are talking security requirements, each group of the requirements needs its own specialist setting and, of course, architectural solutions in order to be introduced into the system. And additionally, developers forget about security and focus more on the functionality of the system, and then this turns out into the vulnerabilities in the system, which leads to leaks of the user's data, for example, or company's data. What is the main problems in the field of security requirements and the requirements engineering? So firstly, requirements engineering is not automatic. So it involves a lot of human power. We need to have like a specialized person, a requirements engineer for it, or maybe a couple of people to like to only cope with the requirements for our project. Second thing is that there is no strict definition of requirements classes, especially for security requirements. So each stakeholder can have its own view on the different classes of software requirements, which leads to ambiguities in documentation and then incorrect implementation of these requirements. The third thing is that we use natural language for requirements documentation, and obviously natural language can be understood differently by different people, which again can lead to ambiguities and incorrect implementation of the requirement. The next thing is that we do not have a proper research in the field of security requirements because it is quite narrow field, and in particular with automation of security automation of analysis of security requirements, we cannot like find a lot of good papers to analyze them and to get some information about security requirements. And finally, as a data scientist, we cannot find clean and big data sets for our models, for our for analysis, because it is quite complicated to create them, and again it has a lot of problems with natural language and ambiguities of it. So let's talk about state of the art in the requirements analysis. Of course, when we are talking about requirements, mostly we are talking about the text, and for the text we have NLP, which is automatic. It can be named as automatic manipulation of natural language by software. So what do we do with NLP? We can classify text, for example, filter spam in our email, predict whether this particular message is spam or not. We can translate from one language to another. We can produce summarization of a text or generate text, for example, for online bots, which can communicate with customers by themselves. And after that, I want to introduce you like some definitions of NLP. And the first definition will be a text embedding. We already had it during the previous presentation, but I want to focus on it again. So what is text embedding? Text embedding is some numerical representation of any text, word, sentence, or article. And of course, when we are talking about machines, machines does not understand our languages, and they need to have some representation to work with it, to analyze it, to perform calculation on it. And for this, we need to have embeddings. And as you can see in the picture, there is an example for word embeddings. You can see that we can encode, for example, cats, dogs, and houses, and then we get a 7-dimensional embedding, and which can be then projected to the 2-dimensional space. And as we can see, cat and kitten are together because their latent representation are closer to each other than, for example, dog and houses, and the same with king and queen. But as you can see, we can also preserve the semantic similarity between not only the sex of the people, but also like, I don't know, position of the people, like in hierarchy. For example, king and queen are together, and men and women also together, but the similarity between man and king and woman queen also preserved in the embedding. So, and the next thing about NLP is transfer learning. It is a technique which uses one model that was previously trained on one task in the second task. So first model usually is big, and it was trained on a more general task. For example, you already heard about BERT. BERT had two tasks of mask language modeling, which is which is prediction of a mask word in a sentence, and next sentence prediction, which means like it will tell whether this particular sentence can be the next sentence, can be after the current sentence or not. And for this, for the first model, we need usually a lot of data. For example, BERT was trained on a 3.3 billion word corpus. And for the second task, we usually need much less data and spend much less time training it. For example, but usually it is still a lot of data, like a couple hundreds of thousands of words. So let's go to the current situation in NLP. As you can see, machine learning started to be like leading direction in NLP quite recently. Firstly, it started with word embeddings, for example, Word2Vec, Glow, fast text, and then it is started to focus on text and sentences, which is transformers, BERT, and Elmo is actually also focused on the word embedding, but I, in current presentation, wanted to focus more on the transformer and BERT. And actually, transformers, which is a different, which is a completely new direction in machine learning and deep learning, now are state of the art in the whole NLP. And what is it? Transformers. Transformers are models that utilize architecture from Attention is All You Need paper, and like named after the model transformer from this paper. And like, what is the main concept in these transformers? These transformers utilize attention, as you can guess. And what is attention? Attention is a technique that mimics cognitive attention. So it will try to put focus on the most important words in a sentence, while trying to predict other words or something like that. And on the picture you can see French sentence "Je t'aime," which means "I love you" in English, and it is visible that if we are talking about "je," which means "I," it will put focus on the "I" word in the English language, as well as "te amo," "te" is you, "amo" is love, and it turned out to be quite useful, and most of the modern models utilize this technique and produce amazing results in different fields. For example, question answering, machine translation, etc., etc. So what do we have right now? After the transformers, there were many models that were based on the transformer and like improved it, made it better, beat other models in benchmarks. For example, some transformer-based models are T5, XLNet, and BERT. And actually, BERT was so good that scientists started to research functionality of a BERT and published improved versions of a BERT. And for example, you heard already about SBERT, which is sentence embeddings, and other improved versions. So BERT is also one of the main focuses in modern machine learning and NLP. And the next thing is one of the examples from requirements engineering research using BERT is Norbert. So Norbert was used for classification of requirements, and it turned out to be very good. It beats all the previous models. However, the data set which was used for the analysis for the benchmark is cannot be it cannot be said that it is quite representative, because it has only 625 functional and non-functional requirements. And as I told you, we need like a couple of hundreds of thousands of words, sentences to fine-tune our model. And so the next thing is, of course, text clustering. But actually, the most important thing is that we need to firstly have good features for our clustering algorithm to work. Because if our features are not good, we cannot produce meaningful clusters. So everything right now depends on the model for text embeddings, which model I will use, or like which technique I will use for feature to produce the features. And my plan for the research is firstly, and the most the most important thing is to create a data set of security requirements, because currently there is not so much data, and I don't think that with this amount of data I can produce some meaningful results using modern machine learning approaches. So we need to analyze documents with requirements. We need to extract requirements that are security requirements, and then fine-tune our model in order to produce some embeddings of these security requirements. After that, I will, of course, try different models, because there are many models, and each model can perform differently. And of course, I will try different clustering techniques. Those are some examples of clustering techniques. And of course, I then will assess performance and how. Of course, we need to firstly analyze the clusters by some metric. And one of the most important metrics is elbow metric. It is used for determining how much clusters do you need in your data, for your data, in order for it to be meaningful, but like not extensive. For example, if you have 1 million of clusters, of course, it will produce a small distance between each of the each of the center of cluster, but it will be meaningless for us, for people. And the other thing is silhouette score, which means like how clusters are separated and how far each cluster from each other cluster is. And then I will try to visualize our clusters and present it to the specialist, and specialists will analyze them and tell me whether it is useful clustering or not. So I think that's it. I'm ready to answer your questions.
Okay, thank you, Nikita. Any questions from the audience? Anyone? Okay, thank you, Nikita. I guess we can end at this point. So we saw several very interesting presentations. Some of them are somehow related in terms of technologies used or topics addressed. So I actually encourage everyone to cooperate, because I guess working together on the similar topics, relevant topics, is one of the better ways to encourage research and have a better results at the end. So I believe you'll continue this types of seminars, and we'll have another one towards March or April when we'll discuss more about the results. Right. With that, I thank you very much for joining us. And if you have any questions, you can always ask your supervisor or anyone, me. And I wish you very nice day and goodbye. Goodbye, everyone.
Thank you. Goodbye.
Thank you.
Thank you. Goodbye.
Goodbye.
Thank you. Bye bye.
Thank you. Bye.
Thank you. Bye bye.
Bye bye. Thank you.